Hello everyone, my name is Paloma Santiago Walker, and in this video I'll be going through exam 3, problem 3.1 for chem 1315, where we are using nucleophilic substitution and elimination at a tetrahedral carbon. So in this problem, we are given a reaction where there are 6 distinct products that could be generated under the conditions shown, either through substitution or elimination mechanisms. And we're indicated that specifically for the E2 elimination mechanism, there are 3 distinct products that could be drawn. And so we have to identify the different products, those 6 different products that could be generated through E2, E1, SN1, and SN2. But before we go in and describe those different mechanisms, let's first identify our leaving group and our nucleophile. So our leaving group in our main structure here, we can identify that as oxygen tennessium. Highlight this right there in pink. And then our nucleophile, we look at our reagents, right? And we can identify that as the oxygen in this compound right here. And so now that we've identified these 2 main components, we can move on to describe the different mechanisms. Let's start with the E2 mechanism. So E2 is elimination mechanism, where there are 2 main steps that are happening simultaneously. First, our nucleophile, which we have identified, deprotonates the hydrogen that is anti to the leaving group. And as that is happening, electrons from that hydrogen bond create a double bond between the carbons, kicking off that leaving group. So here we can identify that really quickly. First, we draw the arrow from our nucleophile to the hydrogen. Then we move from the hydrogen bond to create that double bond, and then kick off the leaving group. We can attack another hydrogen that is anti to our leaving group instead of the one we did in this problem. Instead, we can do it on this carbon, and it's basically the same main steps. So these are 2 of the products that we can get through E2 elimination. And then in contrast, an E1 elimination mechanism is elimination unimolecular. So instead of the steps happening simultaneously, they are distinct steps. The first step is the leaving group departs, forming a carbocation, and this is the rate determining step. It's going to depend on the substrate, and that's going to determine how fast the reaction goes. And so once the leaving group leaves and forms a carbocation, a proton is going to be removed through a base. So in this specific example, right, we kicked off our leaving group through this arrow, but this positive charge is not as stable as it could be, because we can move this charge to a more substituted carbon and make it more stable. So through 1,2 rearrangement, we can achieve that. So we move that hydrogen here, move it up top to that positive charge, and now we have moved the positive charge to a more stable location in our compound. And then we can deprotonate and then create that double bond, shown here. So that's the main difference between E1 and E2. And now moving into substitution, let's start with SN2. So the SN2 mechanism, we can think about it as substitution, nucleophilic, and bimolecular. So the nucleophile, specifically important for the SN2 mechanism, is going to approach the acyl halide through the backside and substitutes the leaving group. So again, these are simultaneous steps. And it's important that it attacks through the backside because it's going to invert our compound. And then the nucleophile will attack from the backside and the leaving group departs. We denote that it attacked in this specific direction through the dashed lines here. So that is SN2. And then moving on to SN1 mechanism. Again, SN2 happened simultaneously. In SN1, this is a stepwise reaction, so these steps are separate. First, our leaving group departs, forming a carbocation. Again, this is the rate determining step, just like in E1. And then our nucleophile will attack the carbocation to give the substitution product. A difference here from SN2 to SN1 is that the nucleophile can attack either face of the flat carbocation, where in SN2 it had to be through the backside. So specifically again, in our example, the leaving group leaves our compound, gets kicked off. But again, our charge is not as stable as it could be. So we use 1,2 rearrangement to move that positive charge to the more substituted carbon. And then our nucleophile can attack the electrophile here we formed. And then we have our final product. And so these are the different products we can get through SN1, SN2, E1, and E2 given this reaction. And thank you for watching.